Hello, my name is Michael and I'm going to show you a bit about software testing. And I have a slideshow we're going to walk you through to get a grip of that area. So, follow me here and let's see what we have for agenda. Basically, what is testing? Why should we do it? And how should we do it? The last thing is about some kind of engineering process that could aid in being really good at testing. So something to bring with us within this presentation is the essence of testing. So this is my definition of what is the core of testing. Let's just say that find the bugs early before someone else finds them. That is the essence, I guess, according to me. And it would be quite useful if I could somehow provide a feeling that my software is adequate, good. A feeling for me and for others. So let's keep this in our back of our heads while we move on and review the area of software testing. So, well, before testing, I said something about bugs, remove the bugs. So software bug is something that is faulty, it's a flaw in my program, it makes the program provide the incorrect output or perhaps makes the program crash. It shouldn't be there. And the process of finding it would be software debugging. That is, how am I actually trying to find the bugs, the flaws in my software? So how do we usually do that? We are, well, as a programmer, at the start of our career, we maybe only walk into the code and randomly tries to find it because we don't really understand our code. But eventually, when we grow as programmers, we find a more structured way to do this debugging. And eventually we find out that, okay, I have a bug, or my friend says I have a bug, but I need to repeat it. That is the first essential step. Repeat the bug, and when I can repeat it, well, then I can sort of trace it down and try to isolate it. And I want to isolate it into a software model, perhaps a class, a file, function method, code construct, and finally it should boil down to one line of code or a part of line of code even. So I always need to isolate the bug, and when I have isolated, I can fix it, and then we do it again and again. So that is the debugging, and it's really helpful if we find a way to do this very, very structured, so to say. But yes, software debugging, that is not the same as testing. Software debugging we do when the bug is there. Testing is sort of, well, depending on when we do it, but it's sort of trying to avoid bugs or find the bugs early and do it in a very structured way to sort of clean our software away from all the bugs. Let me tell you a story from my own experience about software debugging, and it was sort of state changing in my own mindset on being a programmer. And this was sort of a long time ago when I was a student on my second year. I was trying to hand in a C++ assignment, but I couldn't get it to work. And I've been there for a week trying to make it work, but it just crashed, and it crashed in different places. And I haven't learned to use the debugger or debugger core file. So I really didn't know what to do. So I asked the professor. Professor Lars came, well educated, but he just looked at the program. He said, "No, I don't know," he said. So eventually I had to find the bug self. It was a really good feeling when I found it. It was it was like it's usually with C++ and C. It was a memory error, allocation of memory, and I wrote outside it. Could be a bit painful to find and correct these errors. But one thing I took with me from this story is that when I have issues with my code, I am all alone as a programmer. I can ask my friend, but they can't in general not help too much. And when I go out there and work as a programmer, I can't disturb my fellow programmers helping debugging my code. So I need to do it myself. And it helps being structured, and it helps if I write good code at first to avoid all the bugs. Okay, maybe testing can help us there. Maybe. So at least we got some reasons why we should do testing. So we're gonna find the bug and remove them before they appear. So it could easily have spent me or saved me a week of work back then. So this is bug report from a larger project. It's common that in a software development project you will find, or you will get a lot of bugs at the end. So even if you're very good at testing, you will get a problem in the end. So here we see some graphics on unconfirmed and confirmed fixes. So unconfirmed, we could not repeat them. Confirmed can be repeated, and then we have a lot of fixed bugs. But what if we could sort of reduce the amount of bugs? Shouldn't there be some money to earn? Shouldn't we be sort of more profitable as a software company? Maybe if we built better software. But how to do that? Well, then again, test might be one way to do that. Okay, so before we move on into test, let's just cover two terms or terminology that is usually pops up when we talk about tests. So it's verification and validation. It's two forms of testing. And they are usually used to sort of state that we have done the correct software. And verification is being that, are we building the product right? Is the product correct? Does the product have bugs or not? And then we say validation. That is a bit more like, are we really building the product right? Out of all the products we could have built for this customer, did we choose the right one? So if you think of it, you might say it's tomato, tomato. It's the same thing, just different aspects of, is it the right thing we are doing here? But they are usually, the words usually come up when it boils down to testing, and we just say we want to do verification and validation of the product. So let's just keep in the back of our head, we say verification and validation. Yes, that is about testing and showing off that the product is working. Verification is more of the product is correct, it does work. Validation is more of, did we really do the right product here? Should we have built or delivered another product? Different aspects of the requirement specifications. Let's say that. So let's add this for our reasons to do testing. We do testing to show that we have done our verification and validation, and it helps us in showing off that the product is correctly built and works. Let me take one story more. This story is from when I worked as a project manager in a product development company. We did a large product. It was in the class of millions, and we delivered it to the customer, and they had it working. And after 6 months, a year, they called us and said, are your product really working? It seems to be missing money. And it was a money controlling product we delivered to them. And they got the feeling that they lost money. Not much, but it was like a percent or promille. It was a small amount, but when you lose that constantly, day and night, it eventually turns up to 1 million or 2 or 3 or 4. So we did a calculation. We thought that they had lost, well, it was less than 10 millions. Let's take it like that. And this bug was, well, you see the code there. It was about we were building a file of that contains billing data, and we were filling up this file with block, and a block could be filled up with like what was it, like 1024 bytes, and each time a block filled into this sort of file, and the code sample shows that the while loop that sort of filled up the block, it was less than the complete block size, and that was the fault. It should be less than or equal to the complete block size. So once and again, when the block size sort of eventually hit 1024, we lost the block. So it was easy fix, less than or equal to fix, but it was large consequence, and millions of crowns, Swedish crowns that is, was lost by the customer. Oh, so we don't want to end up in that situation. That is why we do test with various inputs. We must do verification and validation of our software. Otherwise it gets so, well, annoying when these things happen. So let's have some quick summary for now. Debugging is easier when the software is small. Okay, yeah. Not hard to understand. Bugs should be corrected as early as possible. Yeah, I buy that also. The feeling of correct software, it's well tested, fulfill the requirements and expectations. Sometimes not only the written requirements, but also the unwritten expectations of how it should work. Don't miss that. And it works with various inputs, like we missed to do testing for in the example I just talked about. So there we go again. Essence of testing this far: find bugs early before someone else finds them. Yeah. And help me provide a feeling that the software is correct and works. Okay, so much about testing. So how should we do it? Is there an engineering process to do this, perhaps? Let's hope so. So let's dive into the processing area of this. How should we do test? When we are developing software, when we are programmers or software engineers, or whatever we want to call us, we should be aware of that there is a sort of standardization called SWE-book, Software Engineering Body of Knowledge, that has sort of a set of competence areas, knowledge areas, that sort of embodies the software engineer, the programmer. That is me. And it's released as a standard, so many people have sort of joined together and sort of written down what it's all about. And in these knowledge areas could be requirements, design of software, construction of software, that is programming, the testing of software, talking about now, maintenance, configuration management, models and methods, software quality. So a lot of areas. And when you are sort of reading this standard, you are usually doing it through a guide. It's a guide to SWE-book, so it's a bit easier to write, to read about these areas. And it's there to get a whole idea of the profession, of the software engineering profession. One part of this book, or one knowledge area, is software testing. And this chapter here, we can see contains fundamentals for software testing. It contains the levels of testing. It contains testing techniques. It contains measurements regarding to testing. It contains processes and tools. Some of the general, there are a lot of testing levels, but let's see some of them here. So we start with unit testing. That is one level of testing where we try to test one unit of software, usually a class or a module. And unit testing is usually done by the programmer who has also written the unit. Function testing is about verifying that a specific feature is doing or working correctly. So we're testing specifically that feature that then could be implemented with many different modules in the background. Integration testing is when we have a lot of modules that must come together to become an application, and we perhaps need to do some testing to verify that the integration actually works. At the end, when the system is complete, we could do system testing. We test the whole system and well, ensures it can work, can be installed, works in its environment, doesn't crash when someone does something, sort of pull the plug to the internet or something like that. Acceptance testing is perhaps the last thing that is done before delivering to the customer. It is our company is doing acceptance testing with the customer, and the customer is sort of signing off, okay, the product is acceptable, it is working according to the requirements. So it's a very important step, because when we have done acceptance testing, we most usually can send the last invoice to the customer. So different levels of testing, doing them in different time of the project or product development. We have different testing techniques. So, well, let's walk through a few of them. So installation testing, that would be try that the software could be installed according to an installation manual or something like that. Compatibility testing is, can my product work in this intended environment? Can it work on Mac, Windows, Linux? Okay, 3 different stages. Okay, let's try all this. Regression testing is a testing technique where when you have implemented a late feature or fixed a bug, and the software worked before, but then you were in there and fixed something, and then you want to assure that you didn't mess up something. You did a correction, but it had side effects that make other parts faulty. So then you want to do regression test. You want to do all the tests again, just because of that small bug. So we call that regression testing. And it's really easy when we have automatic testing and large test beds, test suites. But if you have no testing, you must do manual testing. Ooh, it's going to be real hard to do regression testing again and again. Non-functional testing would be for the non-functional requirements. It could be some quality metrics on how the software should work. I would also say that usability testing is, well, it's usability testing, but it could also be sort of a non-functional requirement, maybe. Usability is all about, can my intended customer actually work? Can they do what they want with the program, and is it usable from the user's aspect? Performance and stability testing would be part of the system testing, where we sort of either aim at testing the performance of the system. Does it work in really what are the response times, and do it work with a high load of users, or well, when it's stressed, what happens? Stability testing also, how stable is the system? So when I put in incorrect values, will it work? What happens if the internet drops? Will it still work? So stability. So different types of testing or testing techniques. And all these must come together into some kind of process where we must do this in a planned, scheduled way. So let's adapt the process. One process could be the waterfall development model. It's a classic one where we do things in steps. First we design the product, then we implement it, and then we test it. So that would be fair to do it like that. Or we could do a bit more like agile or XP development process, where we do it in small steps. We design our program, we code it, we test it, we release it, maybe in 1 week, and then we do another cycle the next week, and the next week. We do it all again. While this waterfall development method, perhaps it's like a month in each phase. So 1 month of programming follows a 1 month of testing. Different types of processes may work good, bad in different situations. One thing is good if we have some kind of process to do automated testing. So that would mean that it's no big cost in executing all our tests at once. So we could do this on daily and nightly basis, and that would really help when we do regression testing. It's really easy to just kick in this automated test bed when we have sort of corrected a bug, added a feature. Really easy to do regression test, which, well, it's a good thing to sort of ensure that the software is accurate. Another type of development process or test process, well, it's both basically, would be the test-driven development, TDD. There we do it like, well, if the other processes here I talked about, they do code and test. Then we sort of swap them in the test-driven development. We do test and then code. We write a test case, and then we write the code to pass that test case. So we sort of wrap them around, and it's I wouldn't say it's fairly popular, but it's a very interesting way of looking at things, and maybe that could be one way of doing it. So there's a lot of different processes. They work, like I said, good and bad in different circumstances, situations. So one should choose the one suitable for just your organization, your team, your customer. So let's take essentials of testing once more. We want to control that the software follows the requirements. We want to show that it works independently on the input received, and it's usable within sort of adequate, reasonable response times. It works in its intended surrounding, producing the results we expect. And this, the third part there, works in the intended surrounding, is a maybe, let's say when we are students, we are just happy that the program works in our environment, and we maybe doesn't really think that it should be working in the teacher's environment or another environment. But that is usually one of the first issues, you will sort of learn that the importance of testing not only your own environment but also other environments is essential. Because the first time you do this, well, you need to go sort of fix your software, and it takes a lot of time to do it, unnecessary time, you think. So both as a student and later on when you work in a real company, do not forget to check that your software works in the intended target environment. What about the industry? Do they really do testing, or do they just ignore it? Do they feel the importance of doing it? I would say it depends a lot of what company you will be working in, what organization, how large is it, what are they doing? Are they doing consultancy work? Are they doing software product works? How mature are they? So all these, well, circumstances will affect how much they will do testing. Maybe they don't do too much testing. They sort of, well, some random test. But on the other hand, on a sort of more mature product development organization, they will most likely do a lot of testing. Well organized, following the plans. We have test plans to show off how we will test our product. Have a plan for all the tests that's gonna occur. The programmer will do their own unit test before they hand on to the test team that sort of does further functional integration, system test. We have an organized way of doing acceptance test when we deliver to the customers. And there is some kind of support and maintenance organization working both with test, validation troubles, and having an organization around it. So it will depend on the organization how well they do this. What about the research? Is it popular to do research on testing? Yes, it's an interesting area. And since we have this, it's commonly believed that it's cheaper to fix an issue earlier than later. So that is a driving force both for the academic to do research about this, but also for companies to be interested in the academic research results. Is there a way to produce better software, earn more money if we just work in another way? So it's a lot of things that the researchers can do. What is the most efficient way of doing test? Measurement of software quality. Could it work with certifications? What about these processes? Should I go agile? Should I go traditional? What is the answer? Should I only do automated testing, or should I do manual testing? So a lot of issues for researchers to look at. And we're closing up. We're reaching the end of the presentation, so let's have this as a memory bank. So why should I do test? Because it's easier to fix a bug when you find it earlier. It's easier and it's costless. If I find the bug directly on my when I'm on my keyboard when I'm working, of course it takes no or limited time to fix it. If my friend in the test team finds it, okay, I have sort of well, it took his or her time, and then the message is going back to me. I must understand what it is, I must troubleshoot it, and then I need to fix it, and then I'm gonna send it to my friend again. So you see, it's a bit more logistic to deal with there. And even if you sort of leave the troubles for the customer, then you will involve the customer, your support and maintenance organization, the test team, and eventually it goes back to you as a programmer, and you fix it, and it takes sort of no time at all. Well, it could take you 10 minutes, it could take you an hour, doesn't matter, because then you must do regression testing, go to the test team, support organization must roll out a new release to the customer, and it must be installed at the customer. And you hear it's a lot of hours that it takes to fix even the smallest issue once you have sort of rolled it out and delivered. So, yay, we're back at the start. Find the bugs early, the bugs, before someone else finds them. Yes, I will do that. And get the tools, techniques, and processes that will help you provide a feeling that your software is correct. It is both essential for your own sake. I know that my software works. And I have facts, a large test bed to sort of push that up. It works. And when I'm confident that it works, and when I have a test bed to show, it will be so much easier to show for my surrounding managers, bosses, project managers, customers, that my software is well tested, verified, validated, it works as expected. Not a problem here with my code. So I think these two, 1 and 2, is really the summary of the whole slide presentation. So I hope you enjoyed this. It was about system testing, and well, I see you shortly again with another topic. Okay, have a nice, bye bye.